I'm going to be talking about QIIME 2 and specifically about this platform that we've been developing for extensible, reproducible, self-documenting microbiome analysis. So QIIME is a platform for microbiome analysis. And so if you're not familiar with the microbiome, this is essentially collections of or groups of microorganisms. And so you have likely heard of the human microbiome, which is the literally trillions of microorganisms that live in and on the human body. This has been getting a lot of press lately. You can see it's very often showing up as cover stories in top journals. The White House just launched the National Microbiome Initiative to continue funding research in this area in the next decade or so. And so this is a very big area, very active area of research right now. QIIME is one of the most widely used platforms for analyzing microbiome data. We published QIIME 1 in around 2009, and according to Google Scholar, we're at just over 5,000 citations now. A lot of this is human microbiome related, but also environmental microbiology related. And we've been steadily increasing in usage since our initial publication. We are now funded through the National Science Foundation to build QIIME 2, which will be designed to address some of the key limitations that we see in QIIME 1. Our user community is primarily biologists, and so in many cases, these are folks who are not trained to work with command line tools, they're not programmers, but they are now dealing with these massive data sets, and they're trying to derive biological insight from those data sets. We interact a lot with our user community, so this map just shows some of the locations of QIIME workshops that we've held. This photo down here is one that we did in South Korea a couple of years ago. And so these usually have about 50 to 100 attendees, and we're teaching them how to use this platform to analyze their data. We also have a very active user forum. And so as of last night, the QIIME 2 alpha release is live. This is a Python 3 package, and it is a complete rewrite of QIIME. And for folks who may have used QIIME 1 in the past, one of the big changes here is that installation is really easy now. So this is all based on Anaconda. And don't take it from me. Go ahead and try it. You can be up and running with this in a few minutes. And so what I'm going to do in this talk is give a bottom-up tour of QIIME 2. So QIIME 2 is based on a plugin architecture. And so all of the microbiome-specific functionality comes in the form of plugins. And so I'm going to talk about what it takes to build a QIIME 2 plugin, so how you can plug into this system, and what that gets you. Then I'm going to briefly talk about our idea of artifacts. And so these are input and output data for QIIME. And then I'm going to walk you through 3 different interfaces. And so we'll look at one built-in interface, which is what we call our artifact API. That'll become clear why in a few minutes. And then I'm going to look at 2 example interfaces. One is a command line interface, and one is a graphical user interface. And these live as separate packages that you can plug into this underlying framework. And so I mentioned that this is an extensible platform. It's extensible both in the sense of adding new functionality through plugins and in adding new interfaces. Okay, so in order to talk about creating a plugin, I'm just going to jump in and I'm going to show you some code. The first thing that you would do if you were a plugin developer is you would define some Python API that performs some microbiome analysis functionality that you want to make accessible to your users. So if we take a look at that, this looks a lot like what you would expect a Python 3 API to look like. And so in this case, we're going to look at a method called beta phylogenetic. And what this is it's a phylogenetically aware pairwise distance metric. And so this is used for computing pairwise distances between microbiome samples. This is just your standard Python 3 API, but you'll notice something that might look a little bit funny to you. These are MyPy style annotations, and so this is valid Python 3 here, and these are optional annotations that we're providing to describe the data type of each of these inputs, and I'll show you why in just a minute. So this function takes a parameter called table, which is a biome table object. It also takes a phylogeny. So this is a phylogenetic tree. It takes a metric, so what specific pairwise distance metric you want to use, and it returns a distance matrix object. And this table, we call these feature tables. And this is a table of samples, so microbiome samples on one axis, and then on the other axis would be, for example, bacterial species. And so that would tell you which bacterial species are present in which one of your samples. And that phylogeny is going to represent the evolutionary relationships between those biological species. So that would be how you would define this API that you want to make accessible to QIIME 2 users. So the next step is you would instantiate a QIIME plugin object. And so you can see up here I'm importing from QIIME plugin. And when I define this plugin, what I'm doing is I'm giving it a name, I'm giving it a version, I'm giving it a website so that users of QIIME know where to go to find more information about this tool. We'll also be including citation information in here so that users can discover who they should be citing when they use this particular analysis method. And then the Python package name. And then the next thing that you would do, now that you've instantiated this plugin, is you can register your function as a method of that plugin. And so what we do here is we describe specifically the function that we want to register. So it's that beta phylogenetic function that we just looked at. We're going to define the inputs to that function. And we're actually going to come back to the types again here. So here we're annotating these types, but this time not with Python data types, but rather with semantic types. And so we're saying that this table is what we call a feature table. And so that indicates some information about what is actually in this data structure that's being provided as input. And similarly, our phylogeny input is of semantic type phylogeny. We have some primitives that we're passing as well here. So remember, we also pass this metric parameter. And so we're saying that's a string, and it's a choice. So we have some available metrics, and we're making those available as inputs to this function. And then our output is called distance matrix, and it is of semantic type distance matrix. We have a name that's used in documenting this or presenting this to a user through an interface. And we have a description, so also for documentation. So at this point, we have defined some API that we want to make accessible. We have instantiated a plugin object, and we've registered that API on our plugin object. And so the last thing that we need to do is we need to tell QIIME where it goes to find that plugin object. And so we just do this by defining an entry point in the setup.py. And so we're saying look in, or for the QIIME plugins entry point can be found here. So this is just that plugin instance that we created. And so at this point, we've done everything that we need to do to make a specific Python API available to QIIME 2 users. And so now let me show you what that gets you. One other thing I want to mention is that this can be very simple. So I just walked you through a few lines of code. The Emperor plugin, which you're going to hear about in the next talk, is only about 75 lines of code total. And that includes all the housekeeping code, so like everything that's in setup.py and so on. So you can do this in, this is very lightweight to develop these plugins. I just want to mention the QIIME artifacts. So this is our concept of input and output data to QIIME. So these are going to contain data. So for example, it would contain all of the information in that feature table, but also some corresponding metadata. And so that would include a UUID, so a unique identifier for this artifact. and also provenance information. So where did this artifact come from? What other artifacts were used in its creation? What code was used in its creation? And we represent these on disk, we represent these on disk in QZA files. QZA stands for QIIME zipped artifact. And these are literally just zip files. And so if you want to interact with one of these outside of QIIME, all you do is unzip that file and you have access to all the data and all of the metadata. Okay, so let me demo some of the things that we can do with this now. Okay, sorry, I'm going to jump over to this window here. What I did before I started this is I just downloaded a few artifacts. So I have a few of these QZA files that I'm going to use as input, but you can also import these from QIIME1 files, and we have a wiki page in our documentation right now. So if I want to interact with these, I'm just going to import an artifact. I'm going to load that artifact. And I'm going to load 2 artifacts. And one of the cool things that you can do with these artifacts is you can take different views of them. And so the function that we just looked at, beta phylogenetic, expects that it's going to get a biome table object as input. But another function that might work with this might want something else as input. And so what you would do is you would just tell that artifact that you want to take a biome table view of it. And so that shows me that I can access that underlying data structure. So I have this biome.table object here. But like I said, maybe we just want to access this as a pandas data frame. So this is just a table. We might want to do something in pandas or seaborn with it. And so we can also take a view of that object as a pandas data frame. And so here, I'm just looking at the first few entries in this object as a data frame. And like I said, these are just zip files. So we have some metadata, we have some data. Okay, so now let's run something with it. Like I said earlier, all of the microbiome functionality that you're going to get is available through plugins. And so the plugins that we're going to look at here, so you can ask QIIME what plugins are currently installed. And here I've got 2. I've got diversity and I've got feature table that I'm going to work with. And so I can import both of those. And I'm going to run a couple of microbiome analyses on these. And so I'm going to run that beta phylogenetic method that I mentioned, or that we just looked at. And I'm just running one more sort of pre-processing step before that. Each of these takes artifacts as input and is generating new artifacts as output. So this distance matrix that I'm getting back here, I'm calling DM. And if I look at that, we can see that that is a QIIME artifact of type distance matrix. We can see its UUID, and so on. We also get some very basic provenance information at the moment. One of the things that we're working on is improving this provenance. But what this lets us get is information about where this artifact came from. And so this is really helpful for reproducibility. So if I have some artifact that I'm talking about in a scientific publication, I can always go back and figure out exactly where that artifact came from. And so this takes that burden off of our biologist end users who may not be as comfortable or really care as much about doing all that tracking. So this shows what artifacts were used to create it. It shows what function was used to create it. It shows what parameter settings there were. And then finally, what I can do is I can just save those to disk. And so I'll just save those as new QZA files. Now, I mentioned the semantic types a couple of times. One of the things that lets us do is it lets us help our users use QIIME correctly. So I said that pre-processing step that I ran is required for this beta phylogenetic metric to give useful results. And so if I don't apply that here, so see I have this table now, this is not the one that I applied that pre-processing step to. If as a user I try and pass that to the beta phylogenetic metric, I'm going to get a type error because I'm passing the incorrect semantic type. So I'm passing something that should not be used with this functionality. Okay, so that is one of our interfaces. And so that's what we call our artifact API, where we have taken that Python 3 API and promoted it to work with these QIIME artifacts. We expect that that's going to be something that is very useful for interactive use. So for example, people using Jupyter notebooks, this is a great way to interact with QIIME. I'm next going to show you our command line interface. And so I mentioned earlier that these different interfaces just plug into the underlying framework. And so the QIIME2 command line interface is driven by this command QIIME. And you can see when I call QIIME, I have some set of commands associated with it. And a couple of those are based on these plugins that I have installed. So the diversity plugin and the feature table plugin. And so if I call QIIME diversity help, I can see what methods are available through this interface, through this plugin. And there's that beta phylogenetic one that we were just looking at. And so you can see here that I have access to that exact same functionality through a different interface here. So these are totally independent interfaces. And this takes that phylogeny, it takes the table, it takes metric. Remember we said that that was a choice, and so the CLI knows how to present what the choices are to the user, and it generates a distance matrix as output. But we already ran that one, so let's run a different interface here. So now I'm going to call this PQIIME method, which is principal coordinates analysis. So this would be something that I might logically apply after generating a distance matrix. And I'm going to do that with the distance matrix that I just generated through the artifact API. And so what this shows you is that you are free to move back and forth between the different interfaces. So for some things, maybe it's more convenient to work with the artifact API or a command line interface. Maybe for other things, you want to work with a graphical interface. So here, this is just a runtime warning that we don't need to worry about right now. But you can see that I just created this new pc.qza artifact. So I just passed one artifact in, got a new artifact as output. The last thing I want to show you in the command line interface is related to plugins. So if I just call this QIIME command, you can see I have my two plugins installed, this diversity and feature table. If I want to install a new plugin, that is just done by conda installing that package. And so I'm installing another package here called Q2Emperor. And if I call QIIME again, you can see that I now have a new command available to me. So I now have this QIIME Emperor command. If I were to go back to my notebook here and look at what my available plugins are, you would see that under this namespace, I also have this Emperor plugin available now. And so these can be very easily added or removed from the system. Okay, so the last thing that I want to do here is I want to demo one more interface. And this is going to be what we call QIIME Studio, which is our first graphical user interface for QIIME. This is an Electron-based interface, and it's available through a source installation right now, but soon this will be available as a regular desktop app. And so again, you can see I have, first I just need to change the directory that we've been working in. You can see these are all my artifacts that we've been looking at so far. I have my plugins up here. And again, I have, for example, this beta phylogenetic function. And so another place where these types come in and how they help us help users is you can see I get these options for what I can provide as inputs. And in this case, it's only showing me artifacts that are relevant for this particular functionality based on their semantic types. Since we already ran one of those, let's use this new plugin that I just created, or that I just installed. And so this generates a visualization based on a principal coordinates plot. And so I'm just giving a name to the output that I'm going to create. I can go ahead and run that. And you can see that that embeds this interactive visualization right here in this new window of the graphical interface. This is a tool called Emperor. It's the subject of the next talk, so I'm not going to go too much into detail right now. I'm just going to kind of show you that we can generate those. When we run that, we can see that this ran a job, and I have one finished job here now. And so I can inspect that, and I can get information about this specific run. And another place where we come back into reproducibility and self-documentation is associated with this job is the exact code that was used to run it. And we have various other ways that I haven't showed you right now where you can do more rich annotation of your code. And so that helps document to your users exactly what it is that a particular workflow is running. And so it gets away from this idea of the workflows being a black box, because you can always dive in and understand what happened in there. You can also see that now I have this one visualization here. So if I come down to this bottom tab, and this is just the visualization that we just created. And so this is that interactive visualization. It's also on my disk as a QZA file at this point. Okay, so I am going to jump back to my presentation now. And I just want to talk a little bit again about what we just looked at. So the first thing I want to point out, and which I hope is clear, is that QIIME 2 is interface agnostic. So you can access these same methods through different interfaces. And this is really good for us and something our users really need, because we've got some users who are, like I said, biologist end users. They don't want to know about the command line. They don't want to use the command line. They just want to do their microbiome analysis as rapidly as they can, get to actually understanding their biological systems, rather than trying to figure out how to copy files to and from a cluster and run commands and so on. And so that allows us to develop, or that motivates us to develop this graphical user interface for some specific end users. We have some folks, maybe our power users, who want to work on the command line. And so we want to make that same functionality available through our command line interface. And so these might be people who are starting many batch jobs, running their analyses on clusters, and so on. And then we've got kind of our data scientist users, or our developers, bioinformatics developers, who might want this artifact API. So they want to interact with these richer APIs that we've created. And of course, if you have somebody who doesn't want to bother with artifacts at all, or they don't want those protections in place, like us saying, oh, that's not a relevant semantic type for the operation you're trying to do, you can always go back to that underlying Python 3 API that I showed you in the beginning. And we call that our view API, because it operates directly on certain views of these objects. The other thing I want to mention is I've been talking about this in the context of microbiome functionality and microbiome analysis, but all of that is not part of the underlying framework. That's defined in the plugins. And so if you are, you're not doing microbiome analysis, but you like these ideas of interface agnostic and self-documenting, you can build your own plugins that don't have any microbiome functionality, and you can just, by not installing our microbiome plugins, you can adapt this to do geology, or you can adapt this to do astronomy, or whatever it is you're interested in. And similarly, you can develop your own interfaces. And so where are we now? So QIIME 2 is far from done. Like I mentioned, we just had our alpha release, and we've got a lot of stuff that we're planning to work on in the near future. We're hoping that this time next year, we'll be ready to do a tutorial for folks who want to develop QIIME 2 plugins. And so we're thinking that we're probably going to propose a SciPy 2017 plugin developers tutorial. And last, I just want to mention that Python 3 enabled a lot of this. And so these are some of the specific PEPs that enabled us to build this functionality in this platform. And so if you're kind of wondering whether it's time to make the transition to Python 3, we've kind of dived in. We think it's ready. We're not doing any Python 2 development at all in our lab anymore. I just want to wrap up with some acknowledgements. I don't have time to mention everybody on here by name, but I do specifically want to mention Evan Bullion and Jay Rideout, who are sitting up there. If you guys could just raise your hands and wave. They did a lot of the design and implementation of this system. This is a big collaborative effort, and we also want to acknowledge our funding from the National Science Foundation, who has specifically funded this project, and the Alfred P. Sloan Foundation and Arizona Board of Regents have provided some funding for some of the initial work that went into this. We're going to be sprinting on QIIME 2 and some of our other projects this weekend, so if you're interested in this or just want to hear more about it, come find any of us, and we'd love to talk with you about it. Okay, with that, I will take any questions if there's time. Yeah. How tied to files is it? So you can interact with the artifacts totally in memory. Right. So I think probably what I would do there, or at least what I'm thinking there, is that like you might be having the QZA files somewhere on disk, and then you would have the UUIDs associated with those, perhaps stored in a database. Okay. Maybe you and I can just chat afterwards, but yeah.
What is the most, you say that the microbiome support is not very far along, but can you describe briefly
What it's doing at this stage? Yeah, so it's not, so I just want to say like it's not yet a replacement for QIIME 1. We've focused on building the framework so far, and so over the next year, we're going to start transitioning our users to this. What we've done so far is we've focused on like what we consider like the downstream analyses. So you've got that feature table, and you want to do analysis of that. Some of the things that we're working on, like so it's got a big suite of alpha and beta diversity metrics, some associated statistics, visualizations. Some of our next steps are now to work on the upstream processing. And so we're working with a few groups on developing methods to start with the raw sequence data, do quality control, and get to that feature table. And then also some things like on the near horizon are some of the newer methods for doing differential abundance testing. So figuring out, is this organism more or less abundant in my disease samples versus my control samples? Yeah.
Any other questions for Greg?